So the final axiom in our list of ZFC axioms is the C in ZFC, so the axiom of choice. And intuitively, what is the axiom of choice saying? Intuitively, the axiom of choice says that if we have some family of non-empty sets, there has to be some way, or there should be some way to choose an element out of all of those non-empty sets. So intuitively, what DFC says, or what the axiom of choice says, is that given a family of non-empty sets, there is a way to choose an element out of each set. So that's informally what the axiom of choice is saying. How do we make this formal? Well, what we need to do is kind of be more precise with what we mean by choosing something. And for us, that's going to be the existence of a function that satisfies a certain property. So formally, what the axiom of choice says is that for each family curly f, so f is just supposed to be representing a collection of sets, there's a function C, so that what happens? For any single element of our family curly f, if A is non-empty, then C of A is an element of A. So what's happening is that our function C is supposed to be choosing an element out of all of our non-empty sets A. So the function C is choosing an element C of A out of each non-empty set. Out of each non-empty set A. So I guess historically the axiom of choice was pretty controversial, but it's not. Mathematicians don't find it very controversial anymore. The way that we're going to use it later is what's going to happen is we're going to be given a set, and what we're going to do is give the set an infinite cardinality, some infinite size. And the way that we're going to be able to do this, it's essential that we're using the axiom of choice in order to do something like this. Some things to, it's also good practice to kind of mention when you're using the axiom of choice. So I'm going to try to do that going forward. What else to say? So the axiom of choice is used not when it's kind of primarily going to be used when our big curly f is an infinite family of sets. So and we can make this a little bit more precise. So note axiom of choice, so sometimes that's written AC, is not needed when curly f is finite. And you can prove that. So you could prove by induction that if curly f had size n, then there's a function C that satisfied this property that we cared about. And the other thing that is kind of something to keep in mind is that it's not needed when we can definably choose an element out of each set. So AC is not needed when we can definably choose. An element out of each set. Well, why is AC not used? Well, we don't need an axiom to assert the existence of a function when we could just kind of write down the definition of what that function would be. The function, the existence of the function is going to be used when we don't know how to define the elements out of each of those sets, or distinguish between the elements in those sets. There's an interesting example. I think this was given. I think this was due to Bertrand Russell, but it was, let's say that we had a bunch of sets. So here's a set here. Here's another set here. Here's our third set, and so on. So maybe here's our set A1, A2, A3, and so on. And well, so he gave two different examples. So the first example is, let's say that all of these sets AI, let's say that they all had one pair of shoes in these sets. So this first set A1, maybe it had a pair of shoes right here. And let's say that the set A2 had another pair of shoes. Maybe it's a different color pair of shoes. And maybe this one had a third colored pair of shoes. And so every single AI had a pair of shoes. If we wanted to choose an element out of each of these AIs, we wouldn't have to use the axiom of choice. And the reason why is that we can distinguish between these shoes. So in other words, we could just choose the shoe that would go on your left foot, for example, the shoe that would go on your left foot, for example. Or you could choose all of the shoes that go on your right foot. We can kind of find a way to distinguish between the elements of the set's AI. But if we change the example a little bit, and so let's say instead of actually, I don't need to erase anything. So let's say instead of shoes, these were all kind of indistinguishable pairs of socks. So each set now had a pair of socks, but there's no way to distinguish between one sock from the other. So there wasn't a left sock and a right sock. It was just kind of they're just two socks that made a pair of socks. Well, then we'd have to use the axiom of choice to choose a sock, because there's no way to kind of tell one sock apart from the other one. Okay, so we're done with listing out all the axioms. What we're going to do next is we're going to start developing cardinal arithmetic. So we're going to the next kind of main goal for us is to write down the definition of an ordinal and start kind of proving some facts about ordinals.